Okay, so I lied in the previous video. Let's take a look at the sampling distribution first. So here, essentially what we're looking at is when we look at the sampling distribution for p. Here are all of my possible values of p hat, right? Centered at p. Now my standard deviation is the square root of p times 1 minus p all over n. And we're hoping, as long as n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, that my distribution is approximately normal. And if that's the case, then I can do normal calculations that I've done since chapter 2 on distributions that involve p, which is actually kind of cool. All right, so let's now go into an example that I would like you to try on your own. So here, this is the check for understanding. Check your understanding. I'd like you to take, I would say 7-8 minutes to do this if you have time. And then we will continue after that. So, teacher in the room, please pause the video at this point to give them some time to do it. And then we will go from there. Okay, so here are my answers. For number 1, I got the mean of the sampling distribution should just be p hat, right? So it should just be p. Sorry, the mean of the sampling distribution should be the same as the population proportion, as long as p hat is an unbiased estimator, right? So it should just be 0.75 because that's what they give us for p. The standard deviation of p hat is, I'm just going to use my formula, the square root of p times 1 minus p over n. And if I do that, I get 0.0137. Now, I have to check my condition, right? The 10% rule to make sure that I can use this binomial, this formula that's derived from the binomial scenario. So n must be less than or equal to 1/10 of big N. So 1,000, right? There are 1,000 within my samples of young adult users. And so there should be more than 10,000 within the population. And since that should be true, then we're okay. And then so number 3, n times p is greater than or equal to 10, and n times 1 minus p must also be greater than or equal to 10. That's to check for normality, right? We have 1,000 multiplied by 0.75, which is equal to 750. 1,000 multiplied by 0.25, which is equal to 250. And both of these are greater than or equal to 10. Therefore, the sampling distribution is approximately normal, right? Hopefully that's what you guys got as well. So yeah. And then last but not least, if the sample size increased, obviously the variability would decrease. And here I just actually did the calculation. And you'll find that this is actually a factor of 3, right? If you take the square root, 9 times that, is actually just, 3 squared, right? So it's actually just by a factor of 3. Sorry. It's 9 times bigger, right? But then if you take the square root, it'll just be 3 times the size overall. Overall, so the variability is 3 times less variable. That's actually the relationship, which is actually kind of cool. Okay, so let's now put all of this together. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home. what is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? So in other words, what this question is asking is, what's the probability that p hat is in between 0.37 and 0.33, right? And if that's the case, then we have to look at the sampling distribution for p hat. So mu p hat is equal to p, 0.35, as long as it's an unbiased estimator, right? And the standard deviation of p hat is just going to be 0.35 times 1 minus 0.35 all over 1,500, and we have to take the square root of that number. Now, if I run the calculations, I'm not going to pull up a calculator, but I have one next to me. And let's see, what do I get? Maybe you guys can beat me to it. But I get 0.0123. Okay, so that's my standard deviation. So about 1%, right? A little bit more than 1%. That's my standard deviation. Now, there are a few things that I need to check before I do any calculations, right? I need to do the 10% rule. N must be less than or equal to 1/10 of big N. So in other words, N must be greater than or equal to 15,000. So I would say there should be more than 15,000 first year college students in the nation. Or is it the nation? And I'll just say in the population, because it doesn't say where it is. Okay? Alright, so that means that we should be good on the binomial set of things, particularly the condition of independence. And then before we do any normal calculations, we need to check to see if the distribution is normal. So n times p must be greater than or equal to 10, and n times 1 minus p must be greater than or equal to 10. If it's approximately normal, then we can do normal calculations, right? So n, 1,500, times p, which is 0.35, is greater than or equal to 10, and 1,500 times 0.65 is also greater than or equal to 10. Particularly, those values are 525 and all the other ones obviously going to be bigger. 975 are greater than or equal to 10, right? So therefore, my sampling distribution for p hat is approximately normal. Oh, also we should define what p hat is, right? P hat is, or let's just define p. P is proportion of first year students attend college within 50 miles of home. Okay? And so, because this is true, then I can do normal calculations, which, you guessed it, is just normal CDF, right? And so normal CDF, 0.33 to 0.37, this is my lower bound and upper bound, with my mean, mu p hat, now I have a proper label of 0.35, and a standard deviation of 0.0123. Okay? And this is standard deviation of p hat. And what I get in this case is, if I plug all of this into my calculator, hang on just a second. I get approximately 0.8961. Please check my work, but that should be right. So, in other words, I have close to a 90% chance of collecting a sample that has a p hat that is within 2 percentage points of the actual value of p, which is kind of cool because remember how I was saying earlier within the year, I can tell you how accurate my sample is going to be, right? But I can't tell you, I can only tell you the chance of my sample being pretty accurate within whatever margin of error. But I can't actually tell you whether my sample is accurate. It is definitely representative of the population or not. So yeah, hopefully that was helpful. That is all that I have for you today. And I will see you on Monday. Bye.